So there's a lot of numerical primitive types that we've learned so far. We've learned whole number ones, such as byte, short, int, and also long. We also learned the numeric primitive types that allows precision. These are the floating ones, such as float and double, right? Now, before we go a bit further, if you remember, I was using an analogy, which was to say that variables were basically boxes. And it was important to know which box to utilize so that we have enough space for it. So that when we have a TV, let's say this is a TV. Sorry for my handwriting or my drawing skills. Let's say this is a TV. When we try to put the TV in a box, well, it won't fit because this box was for a chair or something similar. So we needed to make sure that we had the correct boxes to contain our values. So we needed to have the correct boxes, the correct variables to contain the type of variable, the type of values we want to put in there. Sorry, it's been a long day. So we decided to understand more about variables. We know the sizes of our variables, and this helped us make sure the values we're going to put there, there's enough space for them. However, or not however, interesting enough, sometimes when you're doing things, you'll notice that you could put a box inside of another box. And that's because those boxes are really small. And interesting enough, those values in that smaller box could enter the bigger box without any problems, right? Because that box is smaller than that box. Well, the same thing applies inside our variables. If you guys remember the sizes, as we said that a byte is smaller than a short. It's actually double the size, the short. Integer is double the size of a short. And a long is double the size of an int. The same thing we said for our floating numbers. Double is actually double the size of our float. A 4 byte, well, this is an 8 byte. So it could contain the other one. And because of that, we're allowed to actually put the byte inside of a short, the short inside of an int, the int inside of a long, and also the float inside of a double. Right? This, we call it casting. This is casting because we're converting something into something else. This specifically is called implicit casting. Implicit casting is when your compiler will do the casting for you without any loss of information. So, okay, so let's say no loss of information. Now, mind you, there's something I'm going to point out, and we'll come back to it hopefully in the future, is that when long gets casted into float, there is a little bit of rounding up, rounding down or up, whichever one it is. So in that case, we have a little bit of a loss, I would say. But for now, for our level, we don't really care. So we're just going to specify that we could also cast from long to a float. Okay? And again, it's implicit because the compiler would not cause any issues for us, saying, hey, there's no problem doing this. It looks legit. There's no information that's going to be lost. As an example, we're going to create an integer. Let's call it I for integer. I'm going to put 50 in there. And then I'm going to create a long. Let's call it L. And I'm going to put the I in there. Now, if I print those out, you'll notice that they're both exactly the same value. 50 and 50. Mind you, if the I changes, the L will not, right? We're not copying the variable, we're copying the value inside the variable. So if I ever change the I again to 100, well, now I is going to be 100, L is going to be 50. I is 100, L is 50. Okay, that's a little distinction that we need to remember. We're copying the values when we do this. When we do this casting here, we're still copying the value in that. We're not giving it the location of I. We're not saying, hold on to this guy. Look at this guy. Whenever he changes, you change too. No, no. Okay? So this is called implicit casting. And you'll notice that when we were defining the primitive types, well, the few primitive types we went through, well, actually the variables that we went through, there was a few other types that we've mentioned, right? So we had one that was a Boolean. We had another one that was short. And we have a last one that was string that we specified. Now, the same time as we were mentioning string, I did tell you that string was not a primitive type. And we could notice this easily as just a reminder that primitive types will start with a lowercase variable letter. So you could see it's all lowercase. While a non-primitive type will start with a capital letter, as you could see here. So this is not going to be part of our casting. We can't cast it yet. Okay, we're going to talk about this a bit later. Now, for Boolean in short, let's talk about Boolean first. Remember that Boolean could only have the values of true and false. That was our goal with creating this type. Boolean is true or false. Now, how does true or false convert into any of these? How does it convert to, let's say, integer? Well, it doesn't really. True is not really defined by a number, nor is false, right? We made these variables to make our lives easier, not for the computer. Now, you might see somewhere along where false is 0 and true is going to be any other number. And again, that's a problematic. Any other number means 5 or 7 or 8 or a million. So again, how would we convert that? So again, depending some languages, you might see it being converted to 1 or 0. You'll have to check with that language. But normally, a Boolean casting to any of these will not work. So I cannot do, as an example, Boolean. Let's call it B for Boolean. And I say true. And then I say integer, I don't know, let's say BB. And I say put that B inside of it. Notice I'm going to get an error where it says the required type is integer. But you provided a Boolean. Notice the way the error is being shown. So we can't cast a Boolean to anything else, at least not implicitly. So let's go ahead and delete that. Now, in the case of short, sorry, why am I writing short? Sorry, I'm having I'm really tired and it's 12. So in the case of not short, I was saying character in my mind and I wrote short. In the case of character, it's a bit special. It's a bit special because that every letter that you see inside your system, everything that you see here, all the characters that you've seen, we've talked about it and we said it's all binary. And we talked a little bit about how this binary gets, they take a sequence of it and they convert it to something, so forth, so on. Now, this conversion is normally called an Ascii table. It's an Ascii table where it defines which number equals to what character and so forth, so on. Mind you, our Ascii table have been improved on, and we're getting into these things where we call, I think Java uses UTF-16. A lot of text editors do. A lot of anything, your internet and etc., which is an improvement on the ASCII. So basically this thing is inside of that. Okay, you don't need to remember all of that. Just for now, note that we utilize this ASCII table to convert our numbers, right? This number is our binary, let's say, into the specified character or whatever else. So I did take a, give me 1 second. I did take an ASCII table online just to show you what I mean. So if you go Google ASCII table, you'll get into something similar to this. And you'll notice a couple things. Let me take out my pen for a second. You'll notice the decimal numbers, right? It's a few columns here. What's important for us is the decimal and the character. We're going to ignore the hex and the oct. Now, the character in the decimal, you'll notice the first 127 decimals is something that's also inside our UTF, okay? These 127 contains our main characters that we see. Ignore the beginning part. It's like some, let's say like an escape character and so forth. So I'm gonna ignore those. But let's say from 32, you'll notice that we're getting the space and the symbols, right? And then at line 65, sorry, at decimal 65, we're getting the capital letters. And at line, at decimal 97, we're getting the lowercase characters. Right? Remember we said they were not the same thing because the binary was different. Okay? So because of these ASCII tables, we could actually convert our characters into integers, and we could convert our integers into characters. Okay, so let's bring that back to the other side. So here, if you guys remember, we had the character capital A, let's say, and we have capital A inside of it, and we have the character lowercase a. Again, the variable name, it's the same letter, it's just remember that variable's name has to be something that defines what it contains, and I thought it was the best name. So now if I print out those things, capital A, and if I print out lowercase a, it's going to show me the characters, right? Not the numbers. But I could convert those characters, int IA, and we're going to put a in there, and int I lowercase a, and we're going to put a in there. So now, let's go ahead and print out our integer values and run it. And you're going to notice something interesting. 65 and 97. Do you remember those numbers? So capital A is 65 and lowercase a is 97. Capital letter A is 65 and lowercase a is 97. So the last thing we could do is to actually be able to convert characters into our integers. Implicitly cast our characters into integers. And you might be like, well, why would you even want to do that? What's the point? Well, if I'm teaching it to you, is because you're opening possibilities. But if you really need to have a reason right now, you could think of it as cryptography. If you had to encrypt some message secretly, how would you do it? Well, one of the easiest way to do that, what did I do with my, did I lose my, give me 1 second. One of the easiest way of doing that, let me bring this back up here. It's an easy way of doing that is to convert the character into some other character. So what I mean by that is, what if every character we do +2, whatever the value is. It's an easy to decrypt this, but we could add more math, you know, divide by 3 plus whatever, etc. But if we add +2, so this 65 becomes 67. This 66 becomes 68, and so forth, so on. So this A would be C, this B would be D, etc. So this is a simple encryption. Obviously, if we wanted to, we could go further and make this so complex that, you know, they will never figure out how to open it. Okay? But this is one of the millions of uses you could do by knowing that ASCII is there. Another great thing you could do in there is by doing Ascii Art. So back in the day when graphics wasn't out as much as it is now, people used to make, well, everything was text, right? So people made drawings with those texts. So as a great example, let's go check out some, let's say, bats. And you could see here, these are drawn with just characters. So I could copy paste it and put it somewhere. Going even further than that, people integrated now into something where you could, let's say image, where you could add an image in there. Let me see if this is a good one. So you could add an image in there. Let's go ahead and get a lion. Images. Just quickly, we're going to do this. So let's say this one looks amazing, lion. Save image. All right. Now, there we go. So now that we got our lion, we could put that lion in there. If it let me, it's not letting me. Okay. You could use color, etc. We're just gonna say convert, and you'll notice that that line is being converted into an art, which is with characters. And this becomes really interesting if we talk about how this is done is by using contrast. Anyway, not the point of this course, but ASCII could be really powerful. Anyway, so this is our implicit casting, where the compiler understands that by doing this cast, we're not going to have a loss of information. And that's it. I'll see you guys in the next video.